Hi, Erica. Today I'm going to show you how to use templates. Specifically, I'll show you how to create generic templates where their type are not specified during or are not statically specified, but rather are specified during runtime. Solutions to this will be available on this link here. Um, then under projects tutorials, you'll find the solutions here under stack template implementation in C++. There we have the driver for that, and also we have our class here, or our class template. Alright, I have the solution open on Visual Studio here. I'll start by showing you the driver, or it's just a small simulation just to test and see how everything works. And you can see here, I specify this as double. This is done during runtime, where I'll create a stack of type double, and later on, or further down here, I do create another stack of type in. And again, for strongly typed languages such as C++, where data types are really important, this concept of generic data structures such as this is really important, because you have to create two separate stacks for a double and an int, or you'd have to have two different implementations for this. But using templates, and I just have one implementation, and depending on what I want during runtime, it will create what I want and do everything it's needed to do. Alright, I'm going to show you the class here. So we think of a stack as being a continuous space of memory, or a contiguous memory segment, where in most architectures, think of them as a, a 4-byte space, or spaces which are next to each other like this. So what I'll be doing today is I will have a stack pointer like this, and this will just be referencing whatever we'll be pushing onto the stack, and I will use this to push and pop items into our stack. So okay, the first step here is you see I do define this as a template class here, and this is just class S. S here is just intuitive for stack. This S here will hold the type that we defined during runtime. So if we had a double, this S would be a placeholder for double. Alright, so for our variables, we have size. This just keeps track of the size of our stack. We'll have top, which is just the index of where the stack pointer is pointing at, and this is the actual pointer to the stack. Here's our constructor here. It takes one argument, which is an integer, which just defines the size of stack. We have the destructor here, which just does the garbage collecting, or it removes whatever we dynamically allocate. In this case, will be our stack pointer here. And then we have generic stack functions such as size, push, pop, and empty. All right, let's start with the constructor here. What I'm doing here is I'm just checking if the size of the stack is greater than 0. If it is, if the user define a size that is non-negative and greater than 0, then I will use the size. But if they give me a negative value, since we can't have a stack with a negative or a 0 stack, we just use 5 here, and we'll initialize it to 5 items, or we'll make our stack be able to hold 5 items. Then here, this is a pointer which keeps track of our stacks. We initialize it to -1, meaning if our stack is empty, this should return -1, and that's how we'll know that our stack is empty. And then here we dynamically create our stack, and then depending on the number of items chosen, that will be the size of our stack. Alright, so the first function here is push, which basically, as long as, since it's 0 based, as long as this top of the index of the stack is less than the size of the stack, -1, we can push and return true. So the value that's passed in as an argument here, we do store at this index of the stack and increment the index, which is it just keeps track of our stack pointer, and then we return true, meaning the operation was successful. Else we'll just say false there, and we can't push anything onto the stack. And then pop, as long as top is not negative, we can always pop, meaning the stack has something, so we can go ahead and pop. And since we're passing this value by reference here, it will return the value that we popped from the stack, and we can use that value. Else, if the stack was empty, we can't pop, and we'll return false, and we'll just tell the user what happened or why the operation failed. And top, as long as there is something in the stack, meaning it's not empty, and we've not exceeded the bounds of our stack, we just return whatever is on top of the stack. So again, this gives you, or is a pointer to where the stack pointer is. It's a reference to where a stack pointer is, and so it will return whatever element which is on this index here. Otherwise, we'll just return a null operation message saying that the stack is either empty or we have exceeded the bounds of our stack, and we can't do that, and we'll return -1 just to show that something didn't happen as we expected. Then empty here, as long as there is an element, we'll just say we'll return true, else false. Size just returns the size that the user gave us to begin with, and that will be the size of our stack. So let's see how this runs. We'll first create a stack of type double with 5 elements, and later on create a stack of type int with 5 elements. Let me go ahead and run this. Okay, there we go. So we can see that we did create stacks here. It says the size is 5 as we expected, and then we tried a top here. Since it was empty, it failed and returned -1 as expected. Empty, it returns 1, meaning true as expected since it's still empty. And then we tried popping. Since it's still empty, we do expect this to return failure message, and it does that. And then we continue to push 5 elements here, and they do return true, meaning all push operations were successful. And it tells you the size here is 5 now. And then what is on the top, since it's type double, is 48 here. So it tells you that it returns false for empty as expected, because we do have elements that we just pushed. And then if we try one more push, since we will be exceeding the size of the stack, it returns a 0, meaning it failed pushing, just to make sure we don't go beyond the stack boundary. Same case for the int, the stack of type int here. It does the same thing. The only difference you'll notice is this is 48.00. This is just because this was a type double. This is 48. This was type int, and there's no decimals. Alright, I hope this was helpful. For more tutorials, feel free to go over my other tutorials and the projects on my website. If you have any questions, post them on this video, and I'll respond to them as I can. Thank you, and have a good day.